Welcome to UGC EPG Pathsala. Hello everybody, I am Jitesh Rai, Assistant Professor at Kirudimal College, Delhi University. Today I am going to discuss the module on urban geomorphology. The objectives of today's lecture include to understand the basic themes of urban geomorphology and its role in the planning, development and management of urban areas. Secondly, to discuss the objectives of geomorphological appraisal prior to urban development and during and after urban development. Thirdly, to discuss the examples of the value of geomorphological information in the planning process that includes geomorphology in city planning, site planning, development and post-construction management. And lastly, to understand the relations between geomorphology and other scientific information of value to planners of urban areas that includes environmental impact assessment, impact of environment on development. First of all, I would like to talk about the basic theme of geomorphology, especially urban geomorphology and its role in the planning and development and management of urban areas. Geomorphology is the study of landforms and in particular of their nature, origin, process of development and material composition. Geomorphology is broadly defined as the study of past, present and future landforms assemblies and surfacial process on the earth and other planets. Geomorphology has a valuable role to play in the planning, development and management of urban areas, especially in evaluating terrain prior to urban development and in monitoring changes during and after urban development. The type of information required depends chiefly on the local geomorphology and the responsibilities and altitude of the relevant agencies. It will also vary with the phase of regional planning, city planning, site planning and development and post-construction management all require information that can be provided by the geomorphologist. No doubt, much work in geomorphology is of great potential value to man in his use of the physical environment, and the application of geomorphic knowledge has increased in recent years in harmony with growing public and political awareness of environmental problems, and scientifically because geomorphologists have come to give readers attention to those aspects of the subject of greatest practical application, the dynamic relations between landforms, material and contemporary processes. As far as applied urban geomorphology is concerned, it is the study of landforms and their related processes, materials and hazards in ways that are beneficial to planning, development and management of urbanized areas or areas where urban growth is expected. Geomorphic knowledge is of great significance in deciding the urban growth and urban morphometry in geomorphological fragile zone. Since urbanization is a continuous process of urban growth, it is being affected by several factors. An urban agglomeration denotes a continuous urban spread and normally consists of a town in its adjoining urban outgrowth. Geomorphic aspect plays a great role in deciding the organizational implications. One important qualification must be made about urban geomorphology. Different aspects of geomorphology have been studied in urban areas for many years, not only by geomorphologists but also by engineers and others, some of whom may never have heard of the science. It is not and never has been the exclusive preserve of the geomorphologist. For examples, engineers in Los Angeles have studied the movement of sediment into, through and out of the metropolis for decades, and the information they have collected has been used to predict inter alia the lifespan of reservoirs. Nevertheless, as the field of urban geomorphology is one in which many different aspects of the environment are closely related and can be beneficially integrated, and is also one of rapidly growing knowledge requiring greater specialization among those studying it, it is scarcely surprising that planners and engineers are increasingly either receiving geomorphological training themselves or turning to specialist geomorphologists for help in tackling problems of a geomorphological nature. Recent study suggests that there will be significant variations in the amount of urban expansion. Most of the urban expansion will occur in China. Some specific regions will have high probability of urban expansion. Some regions will have low probability of urban growth. See figure 1 for this detailed analysis. This figure shows the urban expansion probabilities at a global level. Now, I would like to discuss about some important geomorphologists who contributed to geomorphic studies in the past, specifically in urban geomorphology. Wollman was among the first geomorphologists to measure the physical impacts of urbanization on watersheds and stream channels. His studies found that average sediment production rates are moderate to high during pre-urban agricultural usage of land, followed by a spike during construction, and finally a decrease in sediment yield after urbanization. Wollman's study results indicate that the channel response following urbanization is a period of deepening followed by lateral migration and channel widening. These observations of the changes in channel form are consistent with other work carried out during the same time period when fluvial geomorphology in the urban environment was a developing scene. Graff observed the effects of rapid urbanization on the fluvial geomorphology of two small watersheds near Denver, Colorado. He found that the initial impact for these sites was extreme aggradation and increased floodplain access due to increased rates of upslope erosion. The secondary impact after the watershed development was nearly complete and impervious cover in place was vertical incision and downcutting through the previously aggraded material. Arnold, Wisen and P.C. Patton conducted a similar geomorphic and hydrological study of a small urbanized watershed. Elsewhere, in other parts of the world, studies in urban geomorphology have gained ground. Notable studies on this line worth mentioning are Geomorphology and Urban Development in Manchester Area, United Kingdom by Ian Douglas. This work underlined the impact of geomorphology on river dynamics, urban growth, glacial deposits, subsidence, severe collapse and ground conditions. There are also other works such as Urban Geomorphology in Drylands by Cooke, Brunsden, Donkamp and Jones. This study was undertaken as a consequence of serial soil erosion, landslides and widespread flooding where hundreds of people were killed and thousands of homes ruined. The dominant environmental processes responsible for this crisis are geomorphological problems, problems relating to the nature of land surface and the forces that act upon it. In India, the study of urban geomorphology first appeared in 1988. This study was experienced in Mussoorie and its environs by H. Prasad. This study underlined the impact of geomorphology in identifying areas for establishment of new settlements. Attention to urban geomorphology has increased in recent years in harmony with the growing recognition of the importance of the much broader but closely related fields of environmental and urban geology. Urban geomorphology combines the ambient geology, landforms and geomorphological processes with evaluation of impacts brought to these by urbanization. The practitioners of urban geomorphology tend to concentrate on alteration using the ambient physical environment as a baseline. A number of case studies from different parts of the world, specifically dealing with topics such as slope instability, seismic hazards, increased flood problems and land subsidence, have demonstrated the utility of urban geomorphology to engineers, city managers and urban planners. Now, I would like to discuss the objectives of urban geomorphology. First, I would like to discuss the objectives of geomorphological appraisal prior to urban development. The urban planner's primary environmental requirement prior to urban development is a knowledge of the nature and a disposition of natural resources and hazards. The principal objectives, therefore, of surveys designed to satisfy this requirement are the identification of the range of possible locations of resources and hazards, and to analyze conditions within suitable locations to use the environmental resources more economically, beneficially and efficiently. Within these broad objectives, the geomorphologist commonly has several aims. For example, to prevent urban growth from destroying valuable resources. Secondly, to identify and evaluate land and material resources required for development. Thirdly, to limit undesirable impact of urban development on geomorphological conditions. Fourthly, to predict the potential responses of ground surfaces to urban development. And lastly, to assess the potential impact of geomorphological hazards on the urban community. Here, important question is that what kind of approaches do geomorphologists adopt to appraisal prior to urban development? Generally, geomorphologists commonly adopt one or more of the three major approaches to appraisal prior to urban development. First, by far the most profitable and widely used approach is that of formally classifying and describing terrain features through morphological or geomorphological mapping and the interpretation of air photographs or other remote sensing imagery. Second, analysis of process dynamics and landform change may be accomplished through, for example, the analysis of historical records, example, climatic and hydrological data of a region. A third approach is to appraise one poorly known situation by analogy with another similar but better documented situation elsewhere. This approach is, of course, dependent on the availability of data from the analogous situations, and it provides a strong argument for the collection of information in data banks such as that envisaged by the visual network and in deserts. Before urban development, the geomorphological contribution is mainly of importance in providing surveys of direct use in themselves, of value as a source of derivative maps, etc., and as a basis for more detailed subsequent surveys. Now, I would like to discuss the objectives of geomorphological appraisal during and after urban development. During and after urban development, the urban planner normally required to know the effects of natural events and circumstances on the urban community and the impact of urban development on the environment. It is to be noted that the primary interest of the planner is to understand the environmental consequences of urban growth. Within this primary objective, planning and management aims include: number one, the minimization of environmental impact; number two, the development of local, spatial and temporal databases from monitoring studies to formulate the urban development plans; and third, the continuous evaluation of plans, management organizations and procedures to ensure an harmonious environmental management. The main aim of geomorphological work in this context is to monitor the dynamics of geomorphological systems with a view to predicting spatial and temporal changes in a way that allows the planner to respond effectively and in good time. Geomorphological approaches to appraisal during and after urban development are similar to those adopted prior to development, but their relative importance changes. Field monitoring is preeminent, whether it is on a global scale or a city-wide scale. Monitoring often requires the establishment of fixed observation stations. Now, I would like to discuss some examples of the value of geomorphological information in the planning process. First, I would like to discuss the value of geomorphological information in city planning. If in the planning of a new city, the geomorphological surveys are carried out before the settlement of the city, then we can avoid incongruity between the environmental conditions and the city. For example, suppose urban planners making the city plan of a city the first city plan, we can term it as a city plan A, has an attractive spatial geometry, but it would have encountered several problems. For example, building over scarce aggregates, hydrocompaction, flooding, sedimentation and erosion, or roads crossing alluvial fan channels, blowing sand and salt weathering. In the revised city plan, we can term it as city plan B, which attempts to accommodate the implications of the geomorphological map. Most of these problems are either avoided or sensibly controlled, thus saving resources, time and money. At the scale of a whole city, a common problem is that the management of a single natural unit such as a drainage basin is divided between several administrative organizations with the resulting duplication or dispersion of effort and perhaps competition and conflict. This is a problem that can be avoided if environmental criteria are used intelligently in the initial formulation of responsibilities of different authorities, although it would be naive to assume that other factors are not usually more important in such formulations. For example, see the figure 2, which shows the urban cluster growth hotspots detected from DMSP nighttime lights in China at county level and India at district level over 3 periods: 1 1990 to 1997, second 1997 to 2003 and third period 2003 to 2010. Now I would like to discuss the value of geomorphological information in site planning and development. An excellent example of the way in which geomorphological advice can beneficially modify site development plans is provided by Mader and Crowder. He cited the examples from USA's hilly country areas. In 1956, a residential development was proposed in the hill country of the growing settlement of Portola Valley south of San Francisco, California. Subsequent geological and geomorphological studies related to the formulation of the town's general plan and zoning and subdivision ordinances revealed the nature and extent of potential slope instability in the proposed development area. A relative slope stability map showed areas of stable, potentially moving and moving ground and located major landslides. That map, together with other relevant information, formed the basis for a new plan in which houses were clustered on stable ridge crests and the number of lots was only slightly lower than the maximum permitted under the general formula relating lot size to average slope. Even more important, about 15 house sites and some roads on the original plan were removed from actively moving ground and considerably more house sites were removed from potentially moving ground. There are numerous instances where specific geomorphological information might have helped to avoid problems and made the site development process more efficient. Now, I would like to discuss the value of geomorphological knowledge in post-construction management. It is suggested that major environmental hazards can be avoided by monitoring of geomorphological processes and landform changes after construction, and this can also help environmental managers and policymakers in influencing future policy planning. For example, Ruby's study of sediment yield trends in the Los Angeles River catchment is a straightforward example. The accumulation of sediment in debris basin at the mouth of mountain canyons provides a rough measure of sediment yields and allows the performance of smaller check dams to be evaluated. Geomorphologists compared accumulated sediment yields in one canyon, Dunsmore, before and after check dam construction with the regional norm. There are many problems associated with the data and their interpretation, but regression lines relating sediment yield in Dunsmore Canyon to the regional norm for 30 years of records show that for the first 20 years, the canyon performed similarly to the regional watershed, that during the 10 years following construction of check dams, sediment yield from the canyon relatively declined, and that the decline has become progressively less over time. In the period since check dam construction, sediment yield was reduced overall by approximately half, but there now appears to be a trend back to pre-treatment yields, indicating a decline in the trap efficiency of the check dams. Clearly, an alternative strategy for sediment control is required. Before geomorphological problems of any urban development are reviewed systematically, two further introductory themes require examination: the availability of information relevant to geomorphological studies in urban development area, and the integration of geomorphological data into the whole assemblage of environmental data relevant to planning decisions. Now, I would like to discuss the relations between geomorphology and other scientific information of value to planners of urban areas. Geomorphological information forms but one part of the body of environmental data that may be of value to urban planners and engineers. Many environmental attributes of interest are both closely linked and highly interdependent. Data on the regional setting is primarily relevant in assessing hazards and resources and in choosing locations for development. Data on site conditions related to decisions about specific development. On the basis of recent studies, it can be argued that geomorphological surveys can provide a useful first stage in the environmental assessment, not only because geomorphology is a fundamental basis for urban development, but also because studies of geology, soils, hydrology, etc. can all benefit from and be facilitated by access to geomorphological surveys. Now, I would like to discuss the geomorphology and environmental impact assessment. On the basis of recent discussion, it is important to record that demands are increasing from planners for wide-ranging environmental reports prior to making and implementing planning decisions. The most important new requirement is not so much for resource survey, but for studies to evaluate the impact a proposed development is likely to have on the physical environment. Although many planning authorities have required environmental impact assessment for years, recent legislation has enforced and codified the requirement in several countries, providing a substantial stimulus to the development of methods for assessment and for integrating environmental data. The most important new law was NEPA, the National Environmental Policy Act 1969, passed by the US government, and this was followed by similar measures in other countries such as Australia and Israel. To assess potential environmental impact is extraordinarily difficult because it involves predicting complex responses on the basis of what is usually woefully inadequate scientific data. However, political necessity has prompted several attempts to develop standardized techniques of assessment in order to streamline production of reports, to facilitate comparisons, and to simplify the preparation and presentation of complex problems. Now, we also have to understand the impact of environment on development. This theme has much in common with the previous topic, and the techniques of environmental impact assessment mentioned there could well be appropriated here, for clearly cause and effect are intimately related in man's relation with his environment, but emphasis in this field commonly rests mainly on the assessment of natural hazards at different scales. Thus, a major problem of environmental planning at a regional scale is to establish priorities. In this context, assessment of the potential relative impact of environmental hazards is particularly important, and such impacts will vary both spatially and temporally. To conclude this lecture on urban geomorphology, I would like to say geomorphology has a valuable role to play in the planning, development and management of urban areas, especially in evaluating terrain prior to urban development and monitoring changes during and after urban development. Responsibility for studying and managing geomorphological resources, hazards and other problems may rest with a variety of agencies within local hierarchies of management organizations. The type of information required will depend chiefly on the local geomorphology and the responsibilities and altitudes of the relevant agencies. It will also vary with the phase of planning, regional planning, city planning, site planning, development and post-construction management, all required information that can be provided by the geomorphologist. In such circumstances, he must invariably be able to use a wide range of relevant data sources, some of which may be difficult to obtain. Commonly, the geomorphological information must be integrated into a broader assemblage of environmental information that is useful to planners. Among the available methods, it is suggested that those in which geomorphological surveys provide a first stage for environmental assessment may be particularly valuable. Thank you.